Today we're going to be focusing on solving one-step equations with integers. And so I've got a couple examples here that I'm going to walk you through. The first one is a plus 20 equals negative 37. Remember that we always want to use inverse operations when we're solving. So the inverse of add is subtract. And if I do it to one side, then I must do it to the other. And when I'm subtracting integers, negative 37 minus 20, I'm going to use my 3 C's, which is copy negative 37, change subtraction to addition, and change positive 20 to negative 20. And so now I have same signs add and keep. So when I have the same sign, it's a negative, I'm going to keep my negative sign, and 37 plus 20 is 57. 20 minus 20 cancels out, so it's 0, and I'm left with a equals on this side, and a equals negative 57. If I want to go back and check my answer, I can always do that. That's not a problem. So if we plug this back into the original variable, negative 57 plus 20, we want to know, does that equal negative 37? Well, we know that different signs, when we add, we subtract. 57 minus 20 is 37. And we keep the sign with the greater absolute value, which is negative. And so my answer checks and makes sense. A is equal to negative 57. This next one, we have h plus 71 equals 3. The inverse of adding is subtracting. So I'm going to subtract 71 from both sides. 71 minus 71 cancels out and is leaving me with just h. And 3 minus 71, when I subtract integers, I'm going to use my rules copy, change, change. So I'm going to copy the 3, change subtract to add, and change positive 71 to negative 71. Now I have different signs. Same signs we add and keep, but different signs we subtract. So I'm going to do 71 minus 3, which gives me 68. And I'm going to keep the symbol of the greater absolute value, which in this case is a negative. So I've got h equals negative 68. Again, if you want to check your answer, you're welcome to do that. We just plug this back in. So we've got negative 68 plus 71. And we want to know, does that equal 3? Well, when signs are different, we subtract. 71 minus 68 is 3, and keep the sign with more, which is positive. And so our answer makes sense and seems reasonable. It checks that h is equal to negative 68. The last adding example I'm going to do is a little bit unique because we have negative 15 equals negative 5 plus b, and when we add, we know the inverse is to subtract. So this is like subtracting negative 5 from both sides. But we know that when we subtract negative 5 from both sides, really copy, change, change tells us that we're adding positive 5. So if you want to see this as negative 5 and you know that the way to get rid of negative 5 is to add 5, and that's what's going to cancel this out, then you can automatically come over here and add 5 to this side, and it will work. And so over here I'm left with just b. Negative 15 plus 5, different signs subtract. So 15 minus 5 is 10, and keep the sign of the number with the greater absolute value, which is negative. So b is equal to negative 10. Again, we can do a check either on our paper or in our heads. If we come back up here, we've got negative 5 plus negative 10. Same signs add and keep. 10 plus 5 is 15. They're both negative, so negative 15 checks. And I can do a check in my head just like I can do a check on my paper. Either one works. So these are 3 examples of solving equations that started with addition, and then we had to subtract, and then when we subtracted integers, we had to use our copy, change, change rules, and then use our adding rules where same signs add and keep, different signs subtract, keep the number with the higher value, and then you'll be exact.